Hello, in this video, we are going to take a look at a test known as the divergence test. The divergence test is a really basic first check to see, can I tell really quickly if the series is definitely going to diverge? So the divergence test says, if the limit of the sequence is not 0, then the series has to diverge. And some reasoning behind this is, think about that series k equals 1 to infinity of, say, just 1. Every single term is 1. This would equal 1 plus 1 plus 1 plus 1 plus 1, and so on. I would keep adding 1 an infinite number of times. If I'm adding 1 an infinite number of times, there's no way for that to actually come out to be one single number. And the same thing would go for any sequence that doesn't go to 0, because a sequence going to some number L would mean if the limit as k goes to infinity of ak equals L, the series of that sequence eventually, maybe not right away, but eventually will end up looking like that number L added over and over. Might not be exactly that number of L, but the terms will be very close. So it could be like adding a half over and over and over, or adding 10 over and over and over. Or if the limit is 0, it's adding 0 over and over and over. So the only chance a series has to converge is if the limit of the sequence is 0. However, note, if the limit as k goes to infinity of ak is 0, then the series could converge or diverge. Some quick examples of this is, we know the series 1 over n diverges. We've shown that in a couple ways now. But the limit as n goes to infinity of 1 over n equals 0. So here is a case where the divergence test fails. The limit is 0, so we don't know by the divergence test if the series converges or diverges. We ultimately know the series diverges, but the limit of the sequence is 0. However, the series 1 over n squared, this is a p series with p equal to 2, which is greater than 1. So since p is equal to 2, this converges. But the limit as n goes to infinity of 1 over n squared equals 0. So if the limit is 0, that tells us nothing about convergence or divergence. However, if the limit is not 0, then the series has to diverge. So taking a look at a couple examples. The first example is if we are looking at the series k equals 1 to infinity of the arctan of k. Well, if we look at the limit as k goes to infinity of arctan of k, this limit is pi over 2. That's not 0. So the series diverges. So if that limit is not 0, has to diverge. And then, taking a look at this second example, again, look at that limit as k goes to infinity, of our sequence e to the 2k plus 5 over 7 minus 9k. This is equal to e to that limit and that exponent is a rational where we can just look at the powers. The powers are the same. So we look at the coefficients. That is 2 over -9. That is the limit of the exponent, and we still have that base of e. So this limit is e to the 2 over -9. Don't know what that number is, but it's not 0. Because e to a power is never 0. So that series k equals 1 to infinity of the arctan of k. Oh, I'm just reading the line above. The limit. So the series k equals 1 to infinity e to the 2k plus 5 over 7 minus 9k diverges. And for both of these, something we need to add on for if this was a formal need to write out our full answer. We know this is true by the divergence test. Talking about those full sentences again. Our full sentences of conclusion need to be series, converges or diverges by the test with our reasoning. So we have our series diverges by divergence test, and our reasoning is actually shown in our work above. And since we have our work fully showing that reasoning, it is included. And so the divergence test is kind of this background check to say, is it possible for this series to converge? And it's not possible for a series to converge if the limit of the sequence is not 0. So if the limit of the sequence is not 0, the series has to diverge. In the next video, we are going to take a look at more integral test things of what can the integral test tell us beyond convergence and divergence.